Hi guys, I'm going to be going over problem 68 in chapter 14. I'm going to go ahead and read it to you guys. It says, a water tank of height h has a small hole at height y. The water is replenished to keep h from changing. The water is squirting from the hole has range x. The range approaches 0 as y approaches 0 because the water squirts right into the ground. The range also approaches 0 as y approaches h because the horizontal velocity becomes 0. Thus, there must be some height y between 0 and h for which the range is a maximum. In part A, it wants us to find an expression to represent the speed v in which the water leaves the tank at height y. And here I have a small sketch of what is going on. So we have the tank that has a height of h, and there's water exiting the tank at height y. To solve part A, we're going to use Bernoulli's equation, which is written right here across the top. For the pressures at P1 and P2, they're both equal to the pressure at atm. That is because we're looking at what is above this point, and as we can see in P2, there's no water above it, so P1 and P2 will be the same even though they're at different heights. We also have that information given that water is replenished, so the volume of the velocity of water coming in will be 0 because the height never changes. And we will have h1 be equal to h here, and h2 be equal to y. So when we plug all these known values, we are left with the expression down here with these three terms, and we are solving for v2, which is the velocity at which water exits the tank. By rearranging, we are left with v2 equal to the square root of 2 times gravity times the difference between h and y. For part B, we were looking for the expression for the range of a particle shot horizontally from the height y with speed v, and these solutions were given. So we have that the change in t is equal to the square root of 2y over g, and x is equal to the velocity times the square root of 2y over g. And you can find these on iLearn on the through announcements for our physics class. For part C, we are asked to combine the expressions from part A and part B so that we can find the maximum range x max at the height y of the hole. So here from part B, we have that x is equal to v square root of 2y over g, and we want to find the derivative of x with respect to y, and here we find that the derivative after we have done the math is we find that y is equal to h over 2. So once we have our y, we're going to plug it back in here. So x max will equal to 2 times 2h squared over 4 minus h2 over 4 to the power of 1 over 2. And once we subtract this first term from the second one, we're left with 2 times h squared over 4. And once this is solved for, we find the x max is equal to h.